What if I told you there is a super chef who could create any dish you want? You name it, Hakka noodles, biryani, sushi. Yes, he could be able to create that for you. Not convinced, right? But this is exactly the way the modern powerful AI works. Today we discuss about such powerful AI called foundation models which behave exactly like this super chef. Welcome each one of you to the new episode of my YouTube channel Truly AI. I am Dr. C.B. Abraham. I am the super chef. Before I could cook, I had to learn. How did I learn? I was provided with a massive pantry which consists of huge amount of all types of vegetables, groceries, fruits, and in addition, it has all types of data related to cooking like audio, video, image, etc. Also, I was provided with all types of recipes. I could be able to try all the ingredients and recipes and have to learn all cuisines, and I mastered the skill of cooking and I could be able to cook any dish for you. And this is exactly what happens in the case of modern foundation models like GPT, Llama, Claude, etc. AI is provided with a huge amount of data, of diverse data, and it is trained, and this process is called pre-training. In addition to pre-training, as a chef, I could be able to understand the relationship between the different ingredients, the patterns between them, so that I could be able to easily identify which one is similar to the other one, and that way I could be able to get a better clarity about each of the ingredients and their characteristics. And similar is the case with foundation models. There are two aspects: the pre-training as well as understanding the relationship and pattern between the data used in the pre-training. Yes, I can cook anything for you. Suppose you are a die-hard fan of Punjabi food. What I can do? I can retrain myself on special Punjabi menu, and over the process I can become a Punjabi food specialist, something like a butter chicken expert. Suppose you like only South Indian food. In order to cater to your needs, I can retrain myself exclusively on South Indian food. Over the process, I can become a South Indian food expert, something like a dosa master. And this process of moving from a general to a specialized domain is called fine-tuning. Fine-tuning helps a chef to become an expert in that particular type of cuisines. Similarly, using fine-tuning, foundation models could be able to become domain expert. Through retraining, provided with say medical data, a foundation model could become some sort of a medical assistant. Suppose a foundation model retrained with educational content, such a system can become an AI tutor. Foundation model which could be able to provide generalized content using retraining, using fine tuning, foundation model could become expert in particular domain. Fine tuning helps foundation models to provide specialized domain specific content. That doesn't mean that whenever a new information is required, the foundation models need to be retrained or fine-tuned. Since the foundation models are exposed to broader, wider types of data, and it could be able to deal with new types of data on the way. It could be able to learn on the fly. It need not be fine-tuned. It could be able to provide the content because it has been trained on much huge amount of data. Let us have a simple example. Let us ask GPT, can you translate the following sentence to Hindi? Welcome to Truly AI YouTube channel. Here is the translation. Truly AI YouTube channel में आपका स्वागत है. This is what is called on the fly learning. Without having retraining or fine tuning, foundation models could be able to provide newer content because it could be able to learn on the fly. If dosa making make me to learn how to make chapati, because there are a lot of similarities there. The modern foundation models could be able to use this type of information. This is called in-context learning. In the previous example, dosa making is the context. Making chapati is similar to that. Therefore, whatever similarities or pattern in the dosa making could be able to be used in chapati making. Similarly, foundation models could be able to adapt to the new environment. And this mechanism is called in-context learning. Let us have a simple example. We ask GPT, if A is equal to 1, B equal to 2, C equal to 3, and D equal to 4, tell me what is the value of E. It is giving yes. It has given the answer as if A equal to 1, B equal to 2, C equal to 3, and D equal to 4, then naturally E equal to 5. This type of learning, the system has not been exposed to the previous instances, but we have given the context as A equal to 1, B equal to 2, C equal to 3, D equal to 4, and based on that examples or that context, the foundation model could be able to provide the answer to be 5. And that is what the in-context learning. Therefore, there is no pre-training or retraining which we discussed as part of the fine-tuning is needed over here. The foundation models could be able to learn on the fly based on the examples provided, based on the context provided. And that is the beauty of the modern foundation models like GPT, Llama, Claude, etc. There are different flavors of in-context learning. That means foundation models could be able to learn on the fly using examples in different ways. Let us see the first one. The first one is called zero-shot learning. Let us see how does it work. How many letters are there in the English alphabets? Yes, GPT provide the answers 26. We have not given any examples, no context given, and based on the prompt, the machine could be able to provide the answers. This is zero-shot learning. No example, answer is provided. Let us come to the next one, that is called one-shot learning. You guessed it right. One-shot learning means we are giving only one example. If we want to give numerical values to the English alphabets from 1 to 26, and if A is equal to 1, what will be the value of B? Yes, got the answer. If we assign the numbers to the English alphabets starting with A equal to 1, then the value of B will be 2. Therefore, we have given one example, A equal to 1, and we suggest that example, and correspondingly foundation models could be able to come with the answer for the value of B. One short prompt. If you recall the previous example of A equal to 1, B equal to 2, C equal to 3, D equal to 4, what is that? Yes, it is many short learning. How many examples we are giving? Correspondingly, we could be able to have much better mechanism for the foundation model to get the answers correctly. Therefore, we have 0 short learning, no example. 1 short learning, only one example is provided. 2 short learning, 2 examples provided, and many such examples are provided, and correspondingly we have many short learning. Therefore, giving this type of examples help to provide much better context, and giving more examples provide better context, and the machine could be able to provide the better answers. This is what the learning on the fly in context learning. Today I did an experiment. I tried to bake a cake. Let us see. Oh, here is the cake. It looks so beautiful. Let us see. Oh my God. See, it is completely burnt. It doesn't have any taste. How can I give this to my guest? This is what happens sometimes in cooking. Remember, making mistakes is human, right? Chef can make mistakes. Similarly, AI also could be able to make mistakes. There are 2 important ways where AI could be able to make mistakes. The first one, bias. Suppose I am a chef who is specialized in South Indian dishes. Suppose I try dal tadka. Imagine how my dal tadka would look like or taste like. It will be like a typical South Indian sambar, right? Because I have been experienced, I have learned on South Indian dishes, and correspondingly I could be able to provide the responses or outcome only of similar type. Similarly, in AI, when it's trained on some type of data, and when a new idea comes, it is entirely different from the training data. Many times AI could not be able to provide the answer because it is biased towards the data it has been used for training. Second is hallucination. Hello, I am a wonderful chef. Today I have made a wonderful cake for you. I have taken different ingredients from different parts of the world. Look at, so beautiful, so nicely decorated. I give it to you. Have a taste of it. When you taste it, of course, how a burnt cake would taste like. This is what happens sometimes the responses provided by AI. AI could be able to give the responses with full confidence, complete clarity, logically correct, but completely nonsense. Therefore, this type of errors is referred to what is called hallucination. In order to tackle hallucination, we could be able to have many safety measures and we can have many guardrails. And in order to tackle bias, we could be able to use diverse data for training. That way, we could be able to make AI more safer and easy to use for day-to-day activities. Therefore, when AI makes a mistake next time, remember, making mistakes is human. AI also can make mistakes. Modern foundation models are super chef in the modern AI kitchen. Foundation models could be able to generate anything. It can generalize. It could be able to specialize content based on our request. It could be able to learn on the fly with examples, without examples. But the most important aspect, as in the case of kitchen, menu is not fixed. Therefore, the most important question should be not what AI can do, but what we want AI to do for us. Thank you for watching. Please like, subscribe and share. See you in the next video. Till then, truly AI.